Pollution of the environment in which we live and the damage it causes to our health is one of the most important issues in recent years. One of the principal causes of this seems to be the indiscriminate growth of the means of transportation and manufacturing, which produce toxic emissions in the exhaust. To eliminate or reduce this harmful effect makes for cleaner air, and so improves the quality of life. With this goal in mind, Vosges devised and produced the Super Catalyzer. The device was created to improve combustion and reduce the toxic emissions of carbon monoxide, nitrogen oxides, and to reduce unburned hydrocarbons. It also reduces the formation of deposits in the engines and burners through a cleaning action. With regards to automobile exhaust emissions, the Super Catalyzer provides performance similar to the best catalytic converters. How does it work? Basically, it's a matter of permanent, high-powered magnetic fields of 10,000 Gauss, which exert an influence on the fuel. Let's see how. Hydrocarbons can be defined as a group of chemical compounds, composed primarily of carbon and hydrogen atoms, bound to each other by the participation of valence electrons, which have a linking energy. The action of the magnetic field exerted by the Super Catalyzer on the fuel before combustion is shown in the reduction of the linking energy between the carbon-carbon and the carbon-hydrogen atoms. This reduction results in the greater availability of carbon and hydrogen atoms in a particularly reactive form, which we will call radicals. With this combination, intermediate peroxide compounds are formed with the oxygen from the air during combustion, which reacts further with the unburned elements and provides further energy to the system. There is an increase in the speed of combustion, and therefore more energy and heat in the system. Let us now look at the effect of the Super Catalyzer on the combustion process. Following the formation of highly reactive radicalic compounds, which increase the speed of reaction, the following results are also achieved. Total oxidation of the unburnt fuel into carbon dioxide and water. Total recovery of the chemical energy available in the unburnt fuel. A reduction of the suspended particles responsible for the opacity of the exhaust fumes. Combustion occurring with less excess of air. A learner burn. Reduced formation of nitrogen oxides, due to the reduced concentration of oxygen available to combine with the nitrogen in the atmosphere. Reduced engine and burner overhauls and maintenance. In this way, the burners and engines run more efficiently and components last longer. There is less residue buildup, and most importantly, emissions of toxic substances is considerably reduced. The use of the Super Catalyzer also offers the following advantages. Reduction of atmospheric pollution by up to 80%. Reduces fuel consumption by up to 20%. Gasoline, natural gas or oil. The device never requires replacement or maintenance. It can be used with any type of fuel. It can be installed on any type of engine or burner. Those equipped with a turbocharger maintain their turbines at their maximum efficiency. It cleans the valves, the combustion chambers, the exhaust manifold, eliminates the presence of greasy debris and waxy deposits. It also keeps oil burners cleaner. It facilitates the startup of diesel engines by decreasing the viscosity and density of the fuel, even at temperatures below zero. Installation and use of the Super Catalyzer. Industrial applications of the Super Catalyzer are numerous, from small boilers to large refineries, anywhere fuel is used. By adjusting the size of the nozzle, decreasing the fuel pressure, and decreasing the available air to the combustion process, considerable decrease in fuel consumption is obtained and results in close stoichiometric combustion conditions. This results in decreased carbon monoxide, nitrous oxides, and unburned hydrocarbons. Careful monitoring and adjustment of carbon dioxide and oxygen levels or excess air is essential to a perfectly functioning supercatalyzer and combustion process. Open burners, or kilns, have shown up to an 18% decrease in the consumption of fuel. Easier ignition and better control of temperature has been obtained, even with the use of reclaimed oil. Oxygen levels in the exhaust approach perfect combustion.
With the Vasquez unit, we've saved considerable amount of money.
In gasoline vehicles, the device must be installed between the fuel pump and the carburetor or injection system. Results may not be apparent for 3,000 to 4,000 miles due to the cleaning action on the carburetor and fuel lines. Vehicles equipped with a recycling system cause part of the treated fuel not destined for combustion to return to the fuel tank, triggering off by magnetic conduction the phenomena of pre-treatment. This progressively dissolves deposits in the fuel tank, filters and feed lines, as well as decreasing algae growth in the fuel. In diesel engines, it must be installed between the diesel oil filter and the injection pump. With the installation of a supercatalyzer, significant fuel savings are achieved, as well as greater performance and definitely cleaner air.